Today we're going to talk about area on the coordinate plane. So we've already talked about finding the area of basic shapes like parallelograms, triangles, trapezoids. Now we're going to put this on the coordinate plane, which we should already know how to plot points. So that's what we're going to start with. We've got the figure ABCD that has the vertices as follows. We're going to plot those points. So remember, it goes X, Y. So right and left first, up and down second. So 3, 3, 3 to the right, 3 up. I'm going to plot it, I'm going to label it. 3, 6, 3 to the right, 6 up, plot it, label it. 5, 6, 5 to the right, 6 up, plot it, label it. 8, 3. 8 to the right, 3 up, plot it, label it. Then I'm going to connect those points. To make it nice and straight. So now I need to be able to identify what shape this is. Well, it's a four-sided shape, 1, 2, 3, 4, with one set of parallel sides. And if you want to identify that, we've got one set of parallel sides. Therefore, it is a trapezoid. Okay. So remembering the area of a trapezoid is base 1 plus base 2 times the height divided by 2. We've already identified the two parallel sides. Now we've got the perpendicular height as well that we need. Well, let's go around and label the side lengths. So remember, when we're going from one point to the next, we're counting. You're going over once, twice, 3 times, 4 times, 5 times. That is a length of 5. For the height here, you're going up once, twice, 3 times, so it is a height of 3. Here you're going over once, twice, has a length of 2. So now that we have all our measures, we can plug it into our formula. The area equals base 1 plus base 2, so 5 plus 2, times our perpendicular height of 3 divided by 2. Well, 5 plus 2 is 7, so it's 7 times our perpendicular height of 3 divided by 2. 7 times 3 is 21 divided by 2 gives us an area of 10.5. Since we're not given specific units, we're just going to write units squared. We still need to include them, but we're not putting like inches, centimeters, anything like that. All right. This should say number 2. Figure NACHOS, nachos, has the vertices as follows. Find the area. So again, first thing that we're going to do is we're going to label our points. Plot our points and label them. So 1, 1, 1 to the right, 1 up. 1, 4, 1 to the right, 4 up. 4, 4, 4 to the right, 4 up. 4, 9, 4 to the right, 9 up. 7, 9, 7 to the right, 9 up. And 7, 1, 7 to the right, 1 up. And then connecting these points. Okay. When we look at this shape, we realize that it's a composite shape. So what we actually have to do is we need to divide it into 2 rectangles. And there's a couple different ways that you could do it. Then what I'm going to do is I'm going to highlight the base and height of one rectangle. And then I'm going to highlight the base and height of the second rectangle. Now let's figure out what the dimensions are. So we've got 1, 2, 3 on the bottom, 1, 2, 3 for our height. For the second shape, we've got 1, 2, 3 for the bottom, and 1, 2, 3, 4, 5, 6, 7, 8 for the height. So the shape of the first figure is a rectangle, and the shape for the second figure is a rectangle. So when we're finding the area of figure 1, we have our base of 3 times our height of 3, which is 9. For the second figure, we have a base of 3 and a height of 8, which gives an area of 24. Since it's a composite shape, we want to add those together to get the total area, which gives us a total area of 33 units squared. All right, let's look at a word problem here. We've got Katy Perry wants to find the area of her flower garden so she knows how much soil she needs to buy. The coordinates of the vertices of her garden are as follows. If each grid square has an area of 5 square feet, what is the area of her yard? So let's first just figure out the area on our grid, then we can apply it to the real world scenario. So let's plot our points. We've got 1, 1, so 1 to the right, 1 up, 4, 5, 4 to the right, 5 up, 8, 1, 8 to the right, 1 up. Connect those points. Okay, so what shape is this? We have a triangle. So we need to identify our base and the perpendicular height. So that perpendicular height needs to attach to the other vertices. So I'm just going to follow along the line from the vertice down to the base. Then let's figure out the dimensions. So it goes 1, 2, 3, 4, 5, 6, 7 for the base. And our height up 1, 2, 3, 4. So a height of 4. So if we're just looking at the grid, our area is our base of 7 times our height of 4 divided by 2. So 7 times 4 is 28 divided by 2 gives us 14. But what we have to look at is this last sentence here. It says if each grid square has an area of 5 square feet, what is the area of her yard? So this right here is how many units we have. We have 14 square units. We're saying that each square grid here has an area of 5 square feet. So we're going to multiply this by 5 because each of these represents 5, which gives us a total area of 70. And in this case, our units were square feet, so 70 feet squared. All right, one more, and then on to the U-try. HMS is planning to build new bleachers. The coordinates of the vertices are as follows. If each square grid has an area of 4 square feet, what is the area of the bleacher? So again, let's plot our points. We've got 1, 1, 1, 9, 3, 8, 3, 2. Connecting these points. Okay, what shape do we have there? We have a trapezoid. Because it has 1, 2, 3, 4 sides, but it only has one set of parallel lines. Okay, so we need to look for the perpendicular height to the bases. So it really doesn't matter where you meet up. If you want to meet up at the vertice like we did for the triangle, because it was important for the triangles, you can. Otherwise, we can just connect the base 1 to the base 2. And let's write out those dimensions. So we've got over here 1, 2, 3, 4, 5, 6, 7, 8. A height of 8 there. Over here, 1, 2, 3, 4, 5, 6. And then from the base to the other base, it's 1, 2. So first we can plug that into our formula. Base 1 of 8 plus base 2 of 6 times our height of 2 divided by 2. 8 plus 6 is 14 times 2 divided by 2. 14 times 2 is 28. Divided by 2 gives us 14. But again, we've got this word problem here where it asks us if each grid square has an area of 4 square feet, what is the area of the bleachers? So this 14 is representing how many square units on our shape here, but each of these represents 4 square feet, so we're going to multiply that by 4, and we get a total area of 56, and we were talking about square feet, so feet squared. Go ahead and try the U-try.